Let's move on to Mr. Jim Al-Khalili's. Here we go. Okay, well, he starts out um, talking about the atom. And he says the following. He says, we asked where we had come from, how were the stars created, how all the elements were made, even how the universe itself had begun. One of mankind's greatest achievements is that we've answered these questions. Have we? Are you satisfied with those answers is the question, okay? Are they rational, okay? As we peered inwards, we realized we could explain what we saw when we peered outwards, okay? So he's talking about peering into the atom as well as peering out into the cosmos, okay? The atom has helped us solve the greatest mysteries of existence. Oh, has it? I don't think it answered any mathematical physics. It hasn't answered a single issue of existence. So what he's bragging about, I don't know. It's false advertising as far as I'm concerned. Okay, so let's move on here. He says, he continues on with his lecture or presentation. He says, here we have Atom Man. I hope I'm still, okay, I hope I'm still in communication. I'll check every now and then there. Okay, everything in the world we see is made of out of tiny objects called atoms, and yet we've only proved their existence at the beginning of the 20th century. Prove their existence? What is he talking about? You don't prove existence. What do they prove? God? The existence of God? Do you prove space-time? How do you prove these things? And he's talking about proving the existence. Amazingly, we now have a pretty good idea of the number of atoms in the universe. This is a mind-numbingly huge number. It's one followed by over 70 zeros. That's a trillion atoms. So these people say they know how many atoms there are in the universe. First of all, I think it's a waste of time what they've done. But second, are they correct? Do they have a 1 with 70 zeros atoms out there, or is this absolute poppycock? And then you have the issue of, they talk about the observable universe. And they say they calculate that. How can they calculate that when they're telling us that there are virtual particles, positrons and electrons, that pop into existence momentarily? Maybe they participate in some, because they have to show what they're used for. I mean, if they just pop into existence and then back out, who cares? But no, they use the virtual particle very heavily to explain things of why something happened in the lab. That means these virtual particles don't go back into space. They participate actively in our real world. That's what these people are saying. So should we consider those electrons that pop in as being, part of atoms? I mean, were they part of atoms when they were part of space? I mean, we got a problem here. These electrons are just flying around and suddenly they pop in for no reason. They separate. You have an electron here just flying around. We have more electrons in the universe suddenly. And then it goes back into or out of existence. I mean, how can they count the number of atoms if maybe there are more atoms that make up space? Do they have anti-atoms out there in space together with atoms and anti-atoms? And so not only do electrons and positrons pop into existence, but maybe the atom itself pops into existence, in which case we cannot know how many atoms there are in the universe. What nonsense is this about saying how many atoms there are in the universe? How about all the atoms we can't see, all those gases we've got out there? Can you really estimate that? What we do in rational science is we say, look, there's a bunch of stuff out there. How's that for accuracy? Okay? It's not important how many atoms there are in the universe. I don't think even God took the trouble to count them all. Poor God, I mean, his computer must be burning if he counts all those atoms. Okay, anyways, these people say that they counted all the atoms in the universe. That's great. And then he continues on. He says, it's an astonishing, let me get this down here. It's an astonishing human achievement that we now know not only how many atoms there are in the universe, but why they exist at all. They know why the atoms exist, okay? We can now explain how those trillion atoms were created. We're talking about God creation here. They were created. Created from what? It turns out that the mystery of creation itself lies within the heart of each and every atom in the universe. Yeah, have no doubts about it, make no bones about it. Um, General relativity, mathematical physics, is a religion, and they believe in creation. They do use the word creation. They talk about creating matter because that's what they think they do. They think they're creating matter from nothing. What do they call that nothing? They call it energy. What is energy? A concept. What is a concept? Nothing. Okay, you got it? I hope you got the full circle there. Okay, so yeah, there is no. Okay, I hope I'm still connected here. So yeah, there's that issue of where did all this matter come from? Well, that's what we're going to answer here, or Jim Al-Khalili is going to answer this. He begins with a history, okay, of the atom, and he just goes through here. This is a summary. Curie discovers radium, I think 1896, 97. Scientists became alchemists. The first one was Rutherford. And what he did, he put radium in a jar of ordinary air and produced hydrogen gas. He eventually figured out that N2 morphs into O2 and H2. There was your H2 gas in the presence of radium. Radium apparently did something to these gases, broke them apart, and created hydrogen gas. Okay, and he explained the different elements as different number of protons. Okay, that was good. I love that on Rutherford. Okay, he's got he needs to get a kudo on. Okay. However, he couldn't explain weight. That's not my statement. That's Al-Khalili's statement, okay? Because he couldn't explain how helium is supposed to be equal to 2 hydrogen atoms because it's supposed to have 2 protons, and instead it has 4 hydrogen atoms in it, and it has the weight of 4 hydrogen atoms, okay? In fact, not quite as well either there. But the issue is that until Chadwick, 12 years later, 1931, proposed the neutron, they had no idea why, especially helium, was not mass of 2. Instead, it had closer to 4. And they couldn't explain that until they figured out that, oh, helium has a couple neutrons in there, no charge, but has the weight, okay, atomic weight. Okay. But protons don't push each other away inside the nucleus. So you have 2 positive charges, okay? So if these are your 2 protons, okay? If they're both positive, they should push away. And that means the atom should explode, the nucleus, right? And that didn't happen spontaneously. So they said, uh-oh, we got a problem here. And that's when they went into La La Land. Okay, they started going into crazy, inventing ever more nonsense from that point on. They had to explain why protons don't push protons away. And now I recommend that you go get a beer because it's going to get rough, okay, for the mind, okay? What happened? Well, let's get it up here. What we had is that, at least what Al-Khalili explains, he says, if I put some Velcro around these magnets, you have 2 magnets and they push each other away because positive repels positive. Well, if you put Velcro there, that yellow stuff, now you put them together close enough and they'll stick together. Well, no kidding, okay? So at first they repel each other just as before, but when they get close enough, the Velcro kicks in and they stick. The effect is very short range, but very, very strong. In other words, it overpowers the magnetic repulsion, and it overpowers gravity. It overpowers everything. This force, this Velcro that's in there. So we need to figure out what that Velcro is. And it's exactly the same with protons. The strong nuclear force explains what holds the nucleus together. He's saying that Velcro is the strong nuclear force. And he says it's only felt down a distance of a trillionth of a millimeter. In other words, you got to get them close enough for that Velcro stuff to bring the 2 magnets together, the 2 protons together, for them to stick. Okay? Now, is that a sound explanation? Well, absolutely not. And here, let me show you why. Okay, I'll illustrate it first, then I'll explain. Okay, here's why not. Okay, here's Velcro under SEM, under high magnification. And you can see that it's got these hooks when you look at it in magnification. And that's why Velcro sticks to things, okay? Velcro to Velcro and Velcro to carpets and to whatever. Why? Because it's got these hooks. So now, what is the hook in the analogy with respect to quantum mechanics, with respect to the proton? Are they saying that the proton is coated with some kind of Velcro that has hooks and Velcro pulls on Velcro, and that's why you can't separate these two protons? In other words, they don't illustrate. They try to explain with an analogy saying, well, imagine it's like Velcro. You get it close together and then you can't separate them. Yeah, I can understand the analogy. What does that have to do with proton and proton attraction? And they're saying, well, it's like that. Okay, illustrate it for me. Because what you're going to have to illustrate the Velcro on the surface of the proton first. And then you got to show me how the Velcro sticks to the proton to begin with. Okay, so you see where we're going with all this. We got a physical problem. I don't care about their math. I don't care about their measurements. None of that matters. Here we're trying to figure out what is happening in Mother Nature's secret world. And if he's going to use an analogy, he's going to say, well, we explain it with Velcro. Okay, fine. What's the analogy has to serve a purpose. And if Velcro attracts Velcro, what is the Velcro of the subatomic world? And how does that Velcro stick to the proton in the first place? Those are the questions. Okay, and here we have an answer from one fellow, okay? His name was Yukawa, Hideki Yukawa. He was a Nobel Prize winner, okay? All these people get Nobel Prizes what? For doing math. Okay, and what does this fellow say? He says, in one of the protons, an energetic gluon spontaneously creates a down quark and an anti-down quark pair. Okay, let's go slowly here so you understand what's going on. Creates a down quark, okay, and an anti-down quark pair. Next, the pion, okay, drifts. That's another particle, okay, drifts into the other proton. Okay, it's going to drift over there, okay. And the anti-down quark annihilates with a down quark, okay? It's like positive annihilates with negative, okay? They neutralize each other, leaving the other down quark to take its place. So the issue here is they're saying, look, people will probably understand it more with charge because people are more familiar with charge. Imagine there's a positive charge over here and a positive charge over here. Okay, we got two positive charges. Okay, so what we do, we take a gluon, a couple gluons, they go out there and they turn magically, because you can only do this with magic. You turn those two gluons into into a positive and a negative charge. Okay. So the negative charge over here, one of those two negative charges, neutralizes the proton or the quark that was positive, the positive charge, and the other one takes its place, and now you have positive against negative, and now you have attraction. So they explain this mathematically of why, of how there's attraction because north attracts south. That's it. Or positive, negative. They have no explanation. What they say is, oh, we've got the mechanism. The mechanism is you neutralize the positive charge that was repulsing the positive charge over here, okay? And you turn that into a negative charge by doing this gluon fancy footwork. Now you have a negative charge, now they attract. All they're telling you is positive attracts negative. They haven't explained physically what's going on. They said, oh, we just have to show that positive attracts negative. And they go through this rigmarole of changing the polarities. That's essentially what they're doing. They're doing it with down quarks, up quarks, anti-quarks, all that nonsense, or gluons. But that's essentially the mechanism that these people are explaining. They're saying, look, you just have to change the polarity, and then you have attraction. But still, even with balls, you cannot explain why a negative ball attracts a positive ball unless you can illustrate the physical mechanism. And that's where they introduce the Velcro, the little hooks there. Okay, why? Because they can't they can't visualize what's going on in there with particles. With particles, that's the key predicate there. Okay. Okay. He continues on, and here we see how they get into little trouble. Okay, because what? With a strong nuclear force, humans finally began to get a glimpse of what was actually going on inside the atomic nucleus, did they? Roughly speaking, all nuclear behavior is down to a balance between the strong nuclear force squashing, see, he used the word squashing, the protons and neutrons together, and the electric charge on the protons forcing them apart. What these guys are saying, they're using the word squashing because they're suggesting there's some kind of pressure. It's not called squashing. It's called pulling. It's not a question of pressure from the outside. It's the pull from within. That's how Velcro works. Velcro is a pull from within. But see, they use the word squashing. They fit these things in there. He's going to use later on the word squeezing again. They talk about squishing and squishing and squashing and squeezing, when they should be talking about pulling, but they can't use the word pull in quantum mechanics because there is no mechanism of pull in all of quantum mechanics, and there never will be. You can't pull with particles. That's the issue. That's the problem. That's why these people can't answer these questions, and that's why in the end they always say, we don't understand this universe. Of course you don't. Not with particles, because you cannot explain it with particles. But see, that's what he uses, that word squashing. Okay? Protons and neutrons together, and the electric charge on the proton forcing them apart. Okay, so let's continue here. Al-Khalili moves on, and he says the following, going on with strong force. And here it is. You can see it. What they use, those are gluons, those bed springs that you see there. Those are gluons. And what kind of particle is that? Have you ever seen that in the standard model? You'll see the word gluon in there, and they give you some numbers about mass and charge and other nonsense, irrelevant nonsense. But at no point do you ever see a picture of any of those particles. Specifically, you will not see this bed spring. Where are these bed springs when you need them? I mean, I can understand the analogy there, but I don't see the bed springs in the standard model. That's where I have a problem with that. The analogy is inconsistent with a standard model. That's the question. That's the issue. Okay. Okay, and here's just to look at the atom under that model. You have the this is the hydrogen atom. Okay, you have an electron going around, 3 quarks that are being held together by bed springs known as gluons. Okay, and of course, when you ask them, well, what do you mean bed springs? What are those bed springs? Well, you know, that's when they'll give you some math gibberish. They can't justify the bed springs. That's the issue. They can't justify pull, and they're going to talk about what? Squeezing and squashing. Okay. So they use this fancy footwork in their language, and they mislead you. So if you're not in tune with the language, you're going to have problems, because they're going to trick you just with the language. They're going to say, oh yeah, it's squeezed together, squashed together. What do you mean squeezed and squashed? I thought you were talking about pulling, Velcro, you know? Velcro pulls, it doesn't push. Okay, here he tried to make sense, so I put good old Al-Khalili back in his regular image. Okay, how does the sun shine? Good question. Okay, the nucleus of a single atom of hydrogen consists of just a proton, and every now and again inside the high pressure, high temperature cauldron of the sun, this proton can get squeezed. Again, squeezed, not pulled, but squeezed up close to another. See how they trick the language? They're no longer talking about Velcro or using that analogy. It's not pulled or preventing from separation because you got a hook there. No, it's now squeezed together, squashed together. That's how they trick you with the language. And bang, the strong nuclear force kicks in and fuses them together. Again, fuses. The strong force is like coming from the outside, not from the within side, okay? Because they can't explain the force of pull. Keep that in mind. That's the issue. Hydrogen fusing again. That's why they call it fusion, right? Fusing into helium, and the energy released is what we see and feel as sunshine. Now that's strange that he would say that, because the first thing he does is go in there and beat up on Fred Hoyle. okay, who suggested that the elements were created in stars, such as the sun. And there was a big debate between Hoyle and another fellow. His name was George Gamow. And it's George Gamow who's going to lead us into the Big Bang. Okay, if ever you heard of the Big Bang, well, now you're going to know why, how that came about. How did we come up with this nonsense of the Big Bang? Okay, here it is. Let's work on that. Fred Hoyle, he was trying to say the following, okay? He was saying that essentially, right, that the elements, 92 elements, I guess he was referring to all 92, were created in stars, okay? Fred Hoyle explained how elements are created in the stars. Supernovas create heavier elements. You need big explosions, big pressures, etc., big heat, and you get them in supernovas. Okay, one glaring problem, one that Hoyle, this is what Al-Khalili says, okay, that Hoyle could never explain away. Stellar nuclear fusion can't explain how all the elements in the universe are made except for two, hydrogen and helium. In other words, they say they cannot explain those two elements. This was the issue. And Hoyle had no answer for this, okay? To have the amount of helium the sun would have to be burning at billions of degrees, but the truth was that the sun only burned at millions of degrees. You needed billions and you only had millions. That was the issue. The sun just wasn't hot enough to have made all the helium we know that it contains. We got a problem because it turns out that the sun turns hydrogen to helium. I mean, even babies know that, okay, today. That's the theory. You may not agree with it, but I mean, that is the theory. That's the reigning theory, that hydrogen is turned into helium through a fusion process. Here he's saying that that we don't know where all the helium came from. Hydrogen was turned into helium. Period. We're done. And here you see a just one piece of evidence. You'll find it all over the internet. I just collected one because, I mean, you'll see it all over the place. And it says the most important reaction within the core of the sun is the process called proton-proton cycle. Hydrogen nuclei are converted to helium nuclei through a number of intermediates. Okay, and they go through that process, and it says nuclear fusion, the source of all the energy so generously radiated by the sun, does two things. Okay, converts hydrogen into helium. We're done. Okay. And rather makes helium nuclei from protons, and it converts mass to energy. Okay, blah, blah, blah. And there's the reference. So we already are aware that the theory says that hydrogen is converted into helium. But here Al-Khalili denies it or questions it, says it couldn't have made all that helium. Why not? He doesn't explain that. He just says it couldn't. And so he sides with this other fellow, George Gamow. And this guy proposes something else. He proposes that all that, and here it is, okay? Did you get the beer as I asked you to? Okay, here it is. He says that all this happened in the Big Bang, a few minutes after the Big Bang, okay? If all the helium wasn't made in the sun, then where did it come from? Where did hydrogen come from? Was the universe created in a single instant, or had it always been there? And those two questions are all, or the three questions are all related. Why? Because again, George Gamow, and here, let's get this, get it down here. He goes in there and he says, oh, I know where it's all created. It's all the same question. He says, here it is. And the question is, you know, that we created all this in the Big Bang. And by that time, they had developed the notion that all galaxies are going farther apart. That means in the past, they were closer together. When you put them 14 billion years ago, at that time, that's when time was created. That's when the universe came to be. And in a few minutes after the Big Bang, that's when helium and hydrogen were created. That's the origin of helium and hydrogen. Of course, Fred Hoyle didn't like that because he was an atheist, and he said, this smacks at religion, creation. That's what we have today. We have creation. Okay, so if mathematical physicists tell you that theirs is not a creationist theory, they're lying or they're ignorant. Mathematical physics, Big Bang is a creationist theory, And they had to use Big Bang to show why we have hydrogen and helium today so much in the universe. 98% of the universe is hydrogen and helium. And so that's why they had to bring Big Bang. That's why they're not going to let go of that religion, because otherwise, their whole edifice collapses. So they can never deny the Big Bang. That's why they hold on so strongly to it. Okay. Okay. So what have we learned from Mr. Al-Khalili? Here's a summary. Okay. If I can get it up here. Okay. So what did we learn? Here it is, a summary. Atoms answer all questions. That's how he starts his presentation. Protons held together by velcro-like particles. Absolute nonsense. No relation between the analogy that he uses and the standard model. Nowhere in quantum will you find the hooks needed to simulate Velcro, or Velcro simulating the protons. Aside from the fact that you got to stick the Velcro to the proton to begin with. If this Velcro is a little particle, how does it stick to? Does it have glue on its surface and it sticks to the proton? Yeah, this has got to be answered if you're going to give a physical interpretation. Sun shines because protons squeeze together. No. If Velcro is the analogy, then they should be pulled together, not squeezed or pushed or pressured together. Okay. Sun can't produce all the helium. Okay. I don't know where you got that, because the sun is producing helium as we speak. According to the theory. It doesn't mean you have to believe it. Again, this is not a question of belief. It's a question that is the reigning theory. And Al-Khalili is aware of it. So he can't deny it and say, oh, we don't know where the helium came from. What do you mean you don't know? Hydrogen is being converted into helium by the sun. If he doesn't like the quantity because he believes that the sun can't create so much quantity, which they say up to a quarter of the sun is helium, whether it's true or not, I don't know. That's also a guesstimate. We've never peered inside the sun, for one. But then the other issue is, even assuming that were true, we don't know how long the sun's been around. Okay, they say 5 billion years. We don't know. Those are guesstimates. And one guy has one opinion, another guy has another opinion. And again, it's whatever you want to believe, whatever assumptions you want to make. So there's nothing ground in stone that says the sun has 25% of its material be helium, one, and second, that we don't know where it came from. And then he concludes that Hoyle was wrong, that you cannot do this just by supernovas or regular star-like activity. You need the Big Bang. You need a big, enormous explosion. That would create hydrogen and helium, according to them. That justifies why we have Big Bang. And it was proven by Arno Penzias and Robert Wilson when they discovered the background radiation. Okay, in, 1963. They had their antennas. They were trying to get rid of noise. They couldn't get rid of that noise. They found it was the 3 degree Kelvin background radiation from the original Big Bang, or at least that's what they say it is.